Recording in progress, that's a good sign. Exciting. Okay. Well, good morning, everybody. Today is Monday. Happy Monday. We don't have slides for today because today is a discussion. So like I said, if you guys go into BCourses and go into the plotting folder, there'll be like a PDF that has what we're working through today. Should look something like this. Yay. So today we're going to be talking about plotting. The last two lectures, we've kind of talked about plotting in Matplotlib and how to use that package to come up with some really cool figures, both like typical 1D figures like our scatter plots and our like line plots, but also we've looked at ImShow, how to do like 2D figures, like using a little like plt.imshow with the grid. So today's discussion section is just to like hammer in some of those concepts one more time, because plotting is something that like, if you are coding, you typically within the sciences will be plotting. Yeah, even people who are doing theory will have to plot things, unfortunately. If you're coding, you're typically plotting, so it's really, really important to know how to make a good standard plot. If you look at all those cool research papers, they all always have really nice plots because information is sometimes really dense and really difficult to understand. But the moment that you put it on a nice photo, people are like, oh, that makes sense. So learning how to do a good plot, super important. So that's what we're going to work through today. For discussion, you're going to, everyone launch your Anaconda. So we're going to be working in Jupyter notebooks. So I'm gonna, because I'm on Windows, I'm gonna go in my Anaconda prompt and type in Jupyter notebooks. Everyone do the equivalent on your machines. That's not how you spell notebook. I'm also probably not screen sharing, huh? I should fix that. Yeah, I should fix that. Okay, share. Okay, cool. Hopefully now the Zoom will get it. What is that work? Oh, that's fun. Okay, cool. So what I'm gonna do is let everybody take 4, 5-ish minutes, try to talk about the first question, talk to the people around you, try to work through how to do it. Even if you're not able to actually write up the code, we'll write up the code together. I just want like an outline of how you would approach plotting this. So yeah, just talk through it, work through it. If you guys want to mess around and plot stuff, please feel free. And then if you ever have any questions, raise your hand. We'll walk around, come around, help you out. Oh, I also realized I did say we will provide the X values before, and I fully forgot to type in the X values. That's on me. You could just define it as like X equals in space. 3. Okay, sorry to like interrupt whatever you guys are working on, but does anybody want to tell me what the linspace does? Does anybody remember what this does? Any ideas even? Yes. Perfect. Yeah, so when I run this, I'm actually so stupid. I actually can't run this. Why can't I run this line of code? Yep, I have not imported any of my packages. Very silly of me. So I'm going to import numpy as np, import matplotlib.pyplot as plt. Those are the only ones I'm going to need right now. That's running. Yeah. So now when I look at X, it's an array of numbers from 0 to 3. There's 100 data points in it, and they're evenly spaced. Perfect. So you guys can take this as your X array. Cool. Does anybody have any ideas of like how they would start approaching this question? Okay. How about we break it down to this? What is the first step in like initializing a plot? Like what is the first thing that anyone would have to do to tell Python, hey, I'm actually going to start plotting something? There's a little statement that we use from matplotlib that tells us, hey, we're starting a plot. Does anybody know what that line is? Yes. Perfect. So before we even start figuring out how to plot things on our plot, we need to create our plot object. So we're going to do that by, oh wait, let me actually also define y error. I think this is provided for you guys. So this is a y error that you're going to use for your error bars. That should be provided in the file. Okay, cool. So to initialize a plot, we do plt.figure. Perfect. And then as you guys saw, you can put different like little parameters into the plt.figure. Like you can set a figure size, you can do a bunch of things like that. A bunch of optional parameters. You can go on the matplotlib documentation and it'll tell you about all of those. Fig size is kind of the most helpful, the most useful, what we use the most. Cool. So plt.figure is our first step. Now, when we want to plot something, what is the line we use whenever we want to plot a certain data point? All right, go ahead. Yeah, exactly. So we usually use plt.plot. So in the question, we ask you to take the input to the powers of 2 through 5. So the plot should have x squared, x cubed, so on and so forth. So let's say first we want to plot x squared. So we're going to do plt.plot. We're going to do x, and we're going to plot x squared. So our x values are going to be like our x-axis is like the x values and our y-axis is the values that x squared takes. Does that make sense? Perfect. And then in order for me to be able to see this plot, what do I have to do? Perfect. So this makes a little figure sandwich. It makes a little cohesive plot of x squared. Yay. Okay. Well, so the reason it's only showing me like the second half of this like typical quadratic shape is because our x values are only positive numbers. So that's why, like, when you look at the linspace, you're going from 0 to 3 to 100, from 0 to 3. But if I were to change this to something like -3 to 3, you'll see our cute little quadratic. Okay, lovely. So similarly, we can also make plots for x cubed, x to the power 4, and x to the power 5. And then something that we should always do when you have a plot, when you look at this, I'm telling you what it is. It's a quadratic. Now you can see clearly that this is like x squared. But let's say that like you're plotting some data and people don't really know what your data is. So it's always super important to include a title and labels on your axes. So does anyone remember how to include a title on their plot? Perfect, plt.title. And I'm just going to call this like exponential plot. Call it whatever you want. And then does anyone remember how to add labels on the x and y axis? Perfect. So you do plt dot, depending on whether it's the x or y axis, you do x label for the x axis. So I'm going to call this x values, and then plt dot y label. That's going to be my y values, or like the results of the, I'm going to just call them exponents.
Honestly, at some point, you guys will end up being able to guess exactly what the correct function is if you've forgotten it, because coders are really bad at naming things. It's kind of amazing.
This is very true. Okay, cool. So here's our baseline plot. How cute. We see all our little functions. So what is something that like might potentially confuse people here? What do these lines actually mean? Well, we know because we're the ones that coded it that one of them is x squared, one of them is x cubed, so on and so forth. But how would someone just looking at this plot know? They wouldn't. So it's super important to include a legend. And the way you do that is by doing plt.legend. But you will notice that right now I haven't labeled any of my lines. Like, how is Python supposed to know what each line is? We haven't told it. So the way that you do a label is you go into your specific plot statement. So let's say this one's x squared. So I'm going to label it with x squared, so on and so forth. And now when I run plt.legend, I have a legend of what each curve at each color corresponds to. And then you can also change the position of this legend. You can do a bunch of weird things with the legend. Right now, it's like defaulted to what Python thinks is the best location for it. You can put it wherever you would like on your plot. So you can change the location of that legend. You can change the font size of your legend. You can do all that fun, funky, fresh stuff. Cool. So this is our like baseline plot of what we want of the exponents. But we also talked about a little bit of a challenge of maybe figuring out how to write this code more effectively and also including error bars. So I'm going to give everyone like a minute or two to mull over how you might do that. If you look at this code, is there something that's like repetitive, redundant that we can get rid of using something we've learned in Python? If anyone has any ideas, raise your hand, shout it out. Otherwise, feel free to take like a minute or two to think about it and we'll regroup. Yeah.
I don't know, I don't.
You can do this with the X.
Hypothetically.
Yeah.
Okay, I just agree with myself. Yeah, so if you want to see like the full, like, both sides, like, you know how. The errors.
Oh, that's a really great picture.
So to show labels, we need to add plt.legends and that opens like. Cool, so do people have any ideas on how to make this code better? Yes.
Maybe put all of the PLT plots inside of it for you.
Precisely. So it's kind of ugly that we have to do this over and over again. So what we're going to do is write a cute little for loop that's going to like put all of it together for us. So for P in range, does anyone want to tell me what range we're going through here? What numbers are our exponents that we're 2 to 6? Perfect. So 2 to 6 because the last step is excluded. And instead of this, I'm going to do plt.plot x to the power p. Okay, and then does anyone have any ideas on how to handle these labels? Right now, they're like strings that we've manually typed out. Yes.
The way I did it was I did like X and the caret as a string.
Mhm.
And I did a plus I.
Okay, that's fine. You can do a while loop as well, for loop, while loop, either one works. So then you would do plus string, casting it to a string of p. Cool. I'm gonna, haha, that's not how you do that. How do you, there we go. And then I'm gonna keep all these titles, legends, all that stuff the same. And technically this should be the exact same plot as I had before. And it is, yay. Oh, that's not what I meant to do. Yay, exciting, cool. Now, one last component. We talked about adding error bars. So usually error bars are like your Y error is given to you as like an expression or a function. In our case, your Y error is going to be this expression. So the way that you can do error bars in Python, you can use something called plt.errorbar. I'm pretty sure you do it as a separate line. I could be wrong about this. Don't hold me to it. We'll double check once I get there. And then you basically add this parameter called Y error, which is like your error in the Y axis. And we've already defined that as this function here. So you can just do that for your error bars. We'll figure out if this does what I want it to do in just like a second. All right, so we're waiting. I don't know why this is taking so long. Has anyone been able to run this? And does it work with error bars? Does it look wonky? Okay. Fun. It contains negative values. Okay, that's probably because here we've got -3 to 3. For sake of this demonstration, let's get rid of that. Yeah. Thank you, Charlie. So we're gonna go 3 to 3. 0 to 3, sorry. So she puts some fun, funky, and fresh error bars on them. Cool. The error bars look really ugly right now because also like, you know, it's like a margin of error for every single data point. And you have a lot of like, you have 100 data points right now next to each other, which is why you have so many little lines. But that's how you put error bars on a plot, and that'll be helpful when you guys are looking into like statistical error and stuff. Yay. Are there any? Yeah. That's actually such a good question. Why doesn't my legend? Okay, what I assume is happening Let me see. Let me test my little theory. I think plt.errorbar also will just like directly plot things. It does? Okay, well, then you don't need to use plt.plot and plt.errorbar. Plt.errorbar will directly give you a plot. Thank you. Good catch. Great question. But yeah, so you can either use plt.plot if you don't want the error bars, plt.errorbar if you want a plot with error bars. Does that make sense to everyone? Are there any questions?
That error happens when you haven't specified label equals string.
Yeah, so here you know how you have like a label. You need to tell Python what each line is. All right, cool. So that was our first question. Let me see. What we're gonna do is we're gonna skip to question 3 and then we're gonna go back to question 2 and then we're gonna do question 4 just because I want to like mix up different types of plots. So everyone take a quick look at question 3. This one I know will be a little unfamiliar, but the result will be like really, really cool. I think this is like my favorite plot that I've ever produced in this class. So I hope everyone has a fun time with it. What I'm going to ask you to do is try to figure out how to load in data from a CSV file. You can do some Googling, figure it out using NumPy documentation. If there's any questions, let me know. We'll regroup in like a minute or two so we can talk about how to load in a data file. Sound good to everyone? Yay. Just gonna give him like another minute to look at NumPy. Yeah. Oh no, I have 2 more questions. There's 4 questions total. Yeah. I put 4 questions on there because I was looking at the example. I was like, this is not enough. Okay, cool. Did anyone find a way to load in a CSV file using NumPy? Anyone do any like Googling that gave you anything?
If you Googled something, shout out what you got.
Yeah.
Just say it.
Tell us like what you looked up and what you got.
Like that, no.
Good. Perfect. Okay, so you have this cool thing in NumPy. So I'm going to look it up. So this is, you can see that I've looked this up a million times before because the moment I look it up, it autofills. So NumPy load CSV. There's a bunch of different little things. So we're going to go into the actual NumPy documentation. Geeks for Geeks will also tell you how to do it perfectly. I've visited that website many times. So we're going to just assume our data has no missing values because I provided the data file, it has no missing values. So you can see that you can use this thing called numpy.loadtxt. Let's click on it. Yay, we're at the page for numpy.loadtxt. So you can see that it takes in an f name, which is a file name. And then the rest of these are like optional parameters, which is like the data type, a delimiter, all that kind of stuff. Cool. So we're going to do numpy.loadtxt. So something super important, make sure that your CSV file is in the same directory that we're working on this notebook. Otherwise, like you won't be able to find the file. So make sure it's all in the same directory. So the thing we're going to do to load in the data, we're going to use NumPy. So we're going to call it image data. We're going to do np.loadtxt. And the file name should be astro image.csv. Yay. So if this runs, it's going to tell me my data has effectively loaded in. It's a little bit of a large file, so it might take a second. Also, my computer's slow, so a combination of those things. Cool. So that ran. So technically now I have image data. So we can see that this is a NumPy array, right? This looks familiar to all of us. And if you look at like the brackets, does this like look familiar? Like what type of NumPy array is this? Because you have like little arrays within an array. So what kind of array is this? And if you can't tell by visually looking at it, how might we figure out what this array looks like? There's a cool NumPy function that I hope we've talked about that'll give us the size / dimensions of our array.
Oh.
Does anybody know what I'm talking about? It's okay if not.
Take a few seconds to Google it.
How to find the shape or dimensions of a NumPy array. np.shape, perfect. So I'm gonna do np.shape of image data to take a look at what my data looks like. Cool, so we see that it's data that has 1,600 rows and 1,600 columns. So this is clearly two-dimensional data. Cool. Now, does anybody remember how we visualize two-dimensional data? We can't use the line plots and plt.plot that we've usually been using. What do we do instead? Yes, there was like a cool little color plot, right? Do you remember how we got that color plot? Do you remember what we used? ImShow, perfect, cool. So the same way that we, would do any figure, we're gonna initialize it, plt.figure, and then we're gonna do plt.imshow. I'm gonna do image data because that's what we want to plot. Let's just try it with this for now. Let's just see what this shows me. So this is going to be like the most baseline basic plot of this data. And then we're going to look at the power of all these fun little optional parameters that ImShow gives me. So there's something there. It's very hard to see, but that data is not just like empty data, right? Like there's clearly something showing up here. You might not be able to see it on the projector, but hopefully you can see it on your computer. There's like there's a little thing. There's a little shape in there. There's a little image. Cool. Yes. Charlie, could you? Thank you. Cool. Are people able to generate this initial image? Like, give me a thumbs up if it's like, you got a photo. Oh, yes, of course. And does like the process that we took make sense? We just loaded in the data and straight up plotted it. We found out that it was 2D data and we plotted it. Yes.
The shape.
Oh, I just wanted to like show you guys that this is not just one-dimensional like a data array, to prove that it's 2D data. Because then you need to know what type of plot to make. And so sometimes it's important to know what the shape of the data is, because that'll tell you, do I just use plt.plot or do I use ImShow or what do I use? Make sense? Cool. Yes. Okay, cool.
What would happen if you use the wrong one? Like if you use plt.plot for this?
It's actually a good question. So if I did plt.plot of image data, number one, it's basically right now it's going to be really confused because I've given it data, and it doesn't know how to like make it on an XY plane almost. Like, I don't know how else would I describe that? It's like when you have data that's like in the shape of a bunch of rows and columns, Python isn't going to know how to put that on like a one-dimensional line plot. And it's like high key, it's going to keep trying and it's just going to error out at the end of the day. That's kind of like the idea. Like if the data's shape is wrong, it just won't be able to process it. Like you have to be really clear about what type of plot you want. Or it'll process it and do something weird like this. Okay, so clearly it did something, but this is really not what we want. Yeah. So you can kind of also tell, like, obviously this isn't data that we want. So what I'm assuming it's doing here, it's probably like reading every individual row and plotting every individual row as like a line. Which is like unideal. So it probably just, right now it plotted probably 1,600 lines, which is ugly and we don't like it. So we're gonna go back to ImShow. So, but yeah, you should be able to visually like tell kind of most of the time. It'll error out or it'll give you weird images and you'll know your plots are wrong. Cool. So this is ImShow. What I'm gonna ask everyone to do is take a minute or two, open up the Matplotlib ImShow documentation and give me some ideas of how we can make this plot look better. There is data, it is plotted, but how can we make the features on this plot just appear better, look better, highlight whatever's in there more? Because we want to see the cool thing that's going on this image. So take a minute, open up that documentation. Anytime someone has an idea, yell it out, and I'll make a note of it, and we can try different things. Color map. I love color maps. Color maps are my favorite things. So one thing we can do is change the color map. Any other ideas? Okay, cool. Let's just start with that. Let's just start with changing the color map. So, does anyone know how we change the color map on this? Perfect. So you do CMap and then you can give it a color map. I like the color maps of Matplotlib are like my favorite thing ever. I literally have this like tab open 24/7. I have my personal favorites. But there are so many color maps. Like these are all different color maps you can use for whatever different plots you want to make. Some of them have different purposes. So you have like diverging ones. So like the further you're away from zero, the different like colors it'll be. We have cyclic ones that'll just cycle. Qualitative. So if you have like a bar chart and you want like distinct different colors for different numbers, that works. But this little page, a godsend. I love this page. I'm on it all the time. My personal favorite that I like using and I will use all the time is Inferno. So I'm gonna use Inferno. But like feel free to play around with color maps, see which one works best. A lot of times when I'm plotting things, all I do for like 45 minutes is play with colors. And it's fun. Okay, well, it made things clearer, but it is still dark. So I'm gonna try a different color map. Let's try hot. Cool, I think this one's making things look a little better. Sorry, this is really bad on my projector screen. When you do this on your computer, I swear things will look slightly better if you change color maps. Somebody give me a sanity check, yes or no answer to that. They should look better. Okay, we're gonna work in hot for now. But we can see that like, it's still not very clear. It's still not very, you know, apparent. So what we can do, there is a hint for how to do this. We say it in the assignment question. Oh, I also forgot. You want to know what this data that the color corresponds to. And the way you're going to do that, equivalent to like a legend in your 1D plots, you do a plt.color bar. And that'll show a little bar on the side that will, yeah, so this is basically like what the data is. It's showing us these are the values and that's the corresponding colors of those values. Okay. So like it says in our little plotting discussion PDF, we gave you some ideas of how to make this image look better. We can change the vmin, vmax parameters. Now, what do those mean? Let's take a look together. This is ImShow, lib. Again, a page I visit very often, clearly. Cool. So you can see that there is these parameters, a vmin, vmax. And let's go down So Vmin and Vmax basically tells us the range of which, like the range of colors that are being covered in the data. And so by default, it covers a complete value range. So what we're gonna do is like taking a look at this data clearly goes from like 0 to apparently 3,000. But there's likely some data that is like outliery or very high, yada, yada, yada. And so the way that we can still like create a high quality display is by getting rid of those data points. So by setting a max and a min. So these numbers, high key, you kind of just mess around with until they look right, unless you can visually inspect your data. A good starting point is probably to start like 50 up and 50 down from your color bar axis. So here, let's say I start at 50 for Vmin, and I can start at like, I don't know this fact. Yes.
Hi, everyone. If you're having trouble and you're getting a file not found error, please make sure that your astroimage.csv is in the same folder that your Jupyter Notebook is in. If it's not, your Jupyter Notebook cannot see it. Remember the trash can demo I did? It's like that. That's why we do the command line stuff at the very beginning. Because you need to have an idea of where everything is in your computer. There are ways to tell your computer where something is relative to the directory that you're in. Remember, that's called a path. For now, it's a lot simpler to just make sure astroimage.csv is inside the same folder. Cool? Cool. Continue.
All right, cool. So now I just set Vmin, Vmax to be like 50 up, 50 down from my axis. Slightly better, a teeny tiny bit. And then I kind of just like keep messing around. Keep decreasing Vmax was my choice of things to do. Unfortunately, just because it is like a very visual process, like you might have to just run code over and over again unless you can visually inspect data. Vmax I ended up with was 400. This might take a second. Basically, and it's not actually getting rid of any of the data. What it's doing is rescaling the data. So don't like, it's not actually, you see like these numbers, like the range has gone down. It's not because the actual data is changing. What it's doing is it's normalizing the data and then like putting it on a different scale. That doesn't need to make sense to you guys, but all you need to think of it is like, it's basically just reshaping the data to fit the scaling better and to display better. So you can see features better. Mathematically, what it's doing is taking the norm and then like multiplying that by a certain factor to like rescale it. But all you need to do is it's a way to rescale data to make it clearer, to make it more visible, so on and so forth. Does anyone know what this is? The pillars of creation. Cool. So this data clearly is plotting the pillars of creation. I'm going to go back to my favorite color map because I just think it's just cool. So this is so much better than what we started with. So you can see how adding some optional parameters is going to make your data look a lot better. Yay. Some other things you can mess with that I won't go over in super detail just because I want to move on to the next question before class ends. You can change where the origin is. So like if you see how here my 0 on the y-axis is at the top and the 0 at the x-axis on the bottom. That's kind of annoying, and we don't like that. So you can change where the origin is by using the origin parameter. So I can set the origin to like upper or lower or like wherever you want your origin, and it'll like put the zeros together. It'll make the axes run the same way. It's really weird. ImShow kind of just arbitrarily puts axes in a certain way. Did that not do what I wanted it to do? Hold up. But yeah, it'll like align. Oh, this is backwards now. But yeah, so this is backwards now because your y-axis is running in the correct direction. So now they're aligned, but clearly for this data, you want the axes to run in different directions, so. You might just need to mess around with that parameter until you find what works best for the data. Because clearly the data is backwards if you do it this way. So you might want to just keep the origin as a default to upper. And sometimes the axes don't align at 0, and that's okay. As long as you have labels and as long as it's clear which way your axes are running. Like if I was not showing these numbers, that would be a problem. But now that I am, like, you know that the 0 on the Y is at the top and then the 0 with the X is on the left. So that's fine. Cool. Yes.
Is all of this data like temperature data?
It is temperature data. It should, I don't know exactly what form of temperature / brightness / something. It's something in that form. I don't know if it's like like an apparent magnitude, but that genre of data. I don't know what specifically it is. Cool. Does this process for IMSHO make sense to everyone? Lovely. I did spend a lot more time on this than I intended to, but just because I feel like this one's important. I like IMSHO. What I'm gonna have you do, both question 2 and 4, the important part of it is learning how to make a subplot. So what I'll have you guys do for like 2 minutes is take a look at either question 2 or question 4. It's kind of the same principle. We want you to make a subplot. So if anyone can take a second, think about that and like just let me know how to make a subplot. And then you should be able to do question 2 or 4 because that's just like plotting different things on subplots. But the idea is figure out how to do a subplot. I recommend question 2 because it asks for a 2x2 subplot, which is 4 different plots. So that'll help formulate a better understanding. But I'll give you guys like a minute and a half with this. I'm so sorry that it's a little rushed, but subplots are important and I want to make sure to cover at least one example of them. Okay, and then if anyone has any ideas, let me know. For the yeah, so you would need an array for your X values and your Y values for all those different functions. So that is a good starting point. So yeah, let's do that first. Let's create our data. Sorry, I'm gonna mark down this. This one might be a little rushed, so if there's any questions, feel free to come ask me after class. Plus, I have my office hours right after this, so feel free to pop by. So, like we heard, we should do a linspace to generate an array of X values to plot. I'm just gonna go arbitrarily 0, 5 with 100 points. You can do whatever you'd like, but because it's exponential, I recommend this being positive numbers. And then our equations are like, we'll call them Y1 was like X, I believe. So that's how you do an exponentiation. You do np.exp. And I asked for e to the power X, e to the square X. Okay. So I'm just gonna like write out what those. I also fully did format that second one wrong. That should be e to the power 2x. Sorry, my LaTeX went weird. That should be e to the power 2x. And then we're gonna do X plus 1, and then I think it was X minus 1. X minus 1. So now I have all my different things defined. How do I do subplots? How do I get all 4 of these to be on the same figure? Does anybody remember the general structure that we covered? Yes. Perfect. So you do like a fig comma ax. So that's going to tell us like the figure and then how many axes we want on the figure. So like how do we want to break our figure up into different axes? And then how do we define our figure and axes? So like we have 4 plots. So we want them on a 2x2 grid. So we're going to do plt.subplots. And you're literally going to just put in 2 and 2 because it's a 2x2 grid. So that's going to create our figure, create our axes. And then to plot on each axis, you need to specify what axis you want what plot on. And they usually go like, so if I have a grid that's like this way, it's going to go 0, 1, 2, like it's going to go top left. And then like so on and so forth, like it's gonna go row then column. So like a typical like XY kind of grid shape. And you can also like test where plots are by like putting them on different axes if you know what plot it is, and then you can like mess around with the axes. So let's say I just want to plot these four. And then the way that you plot on a specific axis, as I said, you have to define what axis I'm plotting on. So I'm gonna put my first plot on 0, 0. And that's gonna be plot, and then I'm going to put X and Y1, and then I'm going to repeat this process for my 4 plots. This is going to be Y2, and then I'm going to put this on the first row and the 0th column, and then this is going to go on the first row and first column. So those are my 4 plots in my 4 different locations. So remember, Python is 0 index, so when I say 0, 0, I don't mean like nowhere, I mean 0th row, 0th column, which is like technically first row, first column. Cool. So when I do that, I can plot that by doing plt.show. I'm out of time, so sorry, but I just want to show you guys that this will generate subplots, and then you can set separate labels and titles for each one of the subplots. Cool. So those are my subplots. We can see here that like the axes are weird and overlaid. You can fix that by doing a plt.tight layout, I think, or, yeah, right? Yeah, there's like a, basically what, there's a, yeah, there's a thing that'll let you fix that layout. But yeah, you can do slay. But yeah, so that's how you generate subplots. I hope it's clear that like they basically create like an axes grid. Yeah, if you do plt.tight layout, it gets rid of that weird overlap in your labels. But yeah, that's how you make subplots. You can do different titles, colors, whatever for each subplot by using the specific axis object. All right, I hope that made sense. Have a lovely rest of your day. I do have office hours after this, so feel free to come in with any questions about plotting, final project, anything. And yeah, thank you guys.